Okay, this is the fifth and last video for week 2 of CS 1030, and it's going to be about one of my favorite topics, which is debugging. So it turns out that writing programs is fairly easy. And what I really mean this in sort of a narrow sense. What I mean is that, putting code down on the screen is not that hard. Anybody can do it. The hard part is making a program that does the right thing. And you've probably used computer programs that crashed or did the wrong thing. You've probably had, saved passwords get eaten and stuff. I mean, there's all sorts of bugs in computer software, even written by professionals. So the question is, how can we expect you, who are pretty new to programming, to write code that works? And well, it's hard. And in this little segment here, I'm going to talk about some ways that we can try to make sure that programs do the right thing. So bugs in an error in a running program, and there's a quote that I like by one of the most famous computer scientists, Edsger Dijkstra. He said, if debugging is a process of removing bugs, then programming must be the process of putting them in. And it's kind of, unfortunately, a little bit true. When we write code, it's almost inevitable that we're going to put bugs in the code that we're going to have to find and fix later. And it's sort of a bummer. So your absolute main first line of defense against bugs is testing. So testing just means run your program and see if it does what you wanted it to do. And the trick is, what do you test? And this is the real this is the really hard part, because as the person who wrote the program, you know how it's supposed to be used. You sort of know what it's supposed to do and how people are going to interact with it. So it becomes hard for you to test sort of all the crazy ways that people who aren't you are going to use your program. And this, again, is something that not only is a problem for you in this class, it's a problem for me whenever I write code. It's a problem for almost everyone who writes code professionally. It's just hard to imagine all the crazy stuff that people are going to do with your program, and that makes it hard to test. So testing is an activity that requires quite a bit of effort, quite a bit of creativity, and real software projects, that is to say, multi-million-dollar things that are produced out in the world, often spend quite a lot more resources, that is to say, programmer time, testing and debugging, than they do writing the code in the first place. And if that's sort of a bummer to you, or if that's surprising, well, it's a bummer to me too, but that's how things work. So what I would like to help you do is approach debugging with kind of the right mindset. And one of the ways that we don't want to do is just sort of get stuck in a funk where we're frustrated and our program is broken and it's just not productive because it doesn't tell us how to move forward. So the correct mindset is, instead of just saying it's broken, we want to say the program is doing X, but I expected it to do Y. And now the question is, why is it doing X? Why is it doing the thing that we don't want it to do? And we wrote the code. It's all under our control. There shouldn't be any mystery here, but there is, right? Because things can be complicated. So what you want to do is, when your program is doing the wrong thing, you form a hypothesis about what's going wrong inside the program, and then the hypothesis is just an educated guess. I mean, we know this from grade school science. A hypothesis is an educated guess about something, and we test it. And we test the hypothesis by running the program and seeing if the hypothesis is right. If it's right, then we found something that we can change to fix the program. If it's wrong, then we haven't made any progress. We have to come up with a different hypothesis. So, for example, if we look at the program at the bottom right part of the slide here, we might have expected that it would count up to 10 and say 10 at the end when we say count here. But if you look at the program, you can see pretty clearly it's going to count to 11, because it's not going to escape from the repeat until loop until count is greater than 10. I mean, it sort of trivially follows from how this repeat until block works. So we can't escape this loop until count is greater than 10. So of course count has to be more than 10 here. So it's pretty easy to form a hypothesis here. We can sort of look at the loop condition and make an inference based about what's happening. But even in a fairly easy case like this, we still have to be able to do that. And it's not particularly easy. It's not a particularly easy thing to learn or to teach. You basically have to learn this by experience, by running into a lot of bugs. And that's going to be a good part of what you'll be doing as you learn to program, is staring at your code and trying to form hypotheses about what it's doing wrong in order to lead you to the correct fix. So one incredibly important tool at your disposal when you're doing this is to get more information. So what's actually happening inside the program? You want to get visibility into the executing program. You want to see what it's thinking, basically. And one way to do that is to just slow it down, so you can add wait blocks or say blocks, which are basically equivalent to wait blocks. So that's one thing you can do, is slow it down so you can watch it execute. Another thing you can do is have it say lots of things. So here we have it saying the count. So this is going to show us the count every time we go through the main loop. And based on that, maybe we can we can actually watch it roll up to 11. And then we'll understand that, yeah, well, it was already 11 before the loop terminated. So there wasn't some magic process that somehow made count get too big. We can understand the process that happened. So getting visibility into executing code by showing yourself more about what it's doing, that's an incredibly key thing to do. And I want all of you to learn to do this throughout the course of the semester. And in the end, it'll save you a lot of time. So another huge thing that you need to do while programming is called incremental development. And what this just means is write a small amount of code, get a small working program, test it, make sure it does what you want, make sure you understand it, and then add to it. So do not, under any circumstances, sit down and write a huge amount of code without testing it and expect it to work. Nobody can do this. Professionals out in the world can't do it. I can't do it. You're not going to be able to do it either. So the problem there is you're going to write a lot of code. It'll contain multiple bugs, multiple things you don't understand. And when you run it, it's just going to be extremely hard to figure out what the main problem is or what the problems are that you need to fix. So that's not the way to do it. Incremental development means add a little bit of code at a time, keep testing, and then as soon as it breaks, you have to fix it. You shouldn't keep going adding more stuff. And I really can't overemphasize how important this is. This is something that you basically have to internalize if you want to be successful as a programmer. So final thing, and this is hard and sort of a bummer again, is that you need to know what problem you're solving before you solve it. So it's pretty hard to write a program if you don't really understand what the program is supposed to be doing, because there's no way to tell if it's working or not if you don't understand what working really means. And when I say it kind of on a slide here, it sounds sort of like stupid. It sounds like, how could I possibly get into this situation? But just trust me that all of us who've been programming for a while get into the situation where we just are impatient. We just want to start. And we haven't really figured out what's going on. It's okay. I mean, I do it. I've been programming for something like 40 years, and I do this still. But you should just recognize that it's not kind of the easy way. It's not necessarily the fastest way to get to the solution. It's better to try to really understand the problem and then write code that we actually know can solve the problem. Thank you.